We're going to hear from Dr. Samadani, obviously, beyond brain surgery, the neurosurgeon as an entrepreneur. That goes back to what I was saying about the alligator tank. We're very, very excited to have Dr. Samadani. If you go down to the next slide, you'll see it's not only her qualifications or training. You know, we interacted at one point also when we were interviewing together for residency. She was finishing her MD at the University of Illinois. I was also finishing my medical school. She ended up going to train at UPenn, where she did her residency at the University of Pennsylvania. And then you can see she was recipient of several very distinguished awards, including the William P. Van Wagner, which is an extraordinarily tough award to get and very, very prestigious. Went on to become a faculty and currently an associate professor at the University of Minnesota. She was an amazing laboratory. You can see the selected honors and awards. And I had some pictures in my computer of the cover. She made a cover of Top Doctors at in Minnesota, in Minneapolis. Also, I think it was 2018. Her lab has been the recipient of many, many awards that you can see in innovation and ventures. If you go on to the next slide, you'll see some her H index is 28. Continues. You can see the rise of her work as well, and you can see the next slide. Some of her selective publication at a very young age. It's a tremendous amount of work, and I personally have had the pleasure, as we go on to the next slide, of being part of the board of the American Board of Neurological Surgeons. We have examined together. She's got an extraordinarily bright mind, an amazing, person as a physician, as a thinker. You heard already her thoughts about some of her cases. So I'm going to pause right here. Dr. Samadani, we're so delighted to have you. These talks are meant to incite people to think about the way you think about the issues, and we're very, very proud of the work that our team is doing. We're very happy to learn from our colleagues and potentially build bridges. So if we can stop the sharing so we can let Dr. Samadani go ahead and share her screen, and her work. So Uzma, we're delighted to have you here, and we're looking forward to learning from you. And hopefully next year we'll have you here in person. How's that?
Well, first of all, thank you so much, Dr. Quinones. This is absolutely amazing to have this opportunity. I'm super impressed by what you've got going on at Mayo Clinic Jacksonville. I think that you've transformed the place. As Dr. Quinones said, I've known him. He and I met on the residency trail. We were interviewing for residency at the same time. He was sort of my recollection is that he was sort of a quiet guy, and I had no idea what was in store for the world when you became a neurosurgeon. And so I have to congratulate you. As I discussed with him before, I understand they're making a movie about his life. I'm hoping that, I get a cameo in the movie. Maybe, I don't know, Halle Berry, Jennifer Lopez. I'm not sure exactly who will play me, but Dr. Quinones has told me that it's a fiction movie anyway, so we may as well go all out. So on that note, I think what I'll do is I'll give my grand rounds, and then hopefully, if there's opportunity for questions, we can address those at the end. I'm delighted to be here. It's absolutely my pleasure to be invited. And so, I'll start with that. The topic that I'm going to talk about is beyond brain surgery, the neurosurgeon as entrepreneur. And a little bit of this is preaching to the choir, because I understand that many of you at Mayo have already started companies and have done the startup route and have been incredibly successful. So feel free to chime in during the chat, or we can talk about it after. With your tips and pearls, because I'm sure there are others here who are equally experienced, if not more, and have plenty to contribute. As Dr. Quinones said, I'm at the University of Minnesota. I'm part of Bigby, and I work at the VA 1 day a week, and I've just gone into private practice. I'm not as active on social media as I should be, because everybody should be active on social media, but I am on Twitter. So if people want to tweet, feel free to tag me. These are my disclosures. Obviously an important part of starting a company is doing your disclosures, because this is the kind of stuff that can get you in trouble. So those are my sources of funding and honoraria and consulting fees. And then I also have some intellectual property, some of which will be discussed during this talk. So just as a background, you suppose you want to do a startup. One of the things that you can do is read some of the books about startups. And this is from a book called Scaling Up. And what this book starts with is the idea that if you look at the data on startups, 28 million startups were started over a period that was studied. And of those, 96% achieved less than 1 million in revenues, after a certain period of time. Only 4% made it to greater than 1 million. 0.4% made it to greater than 10 million. And of those 28 million companies, 17,000 made it to greater than 50 million. And when you think about this, what this means is the probability that a startup will be wildly successful is actually incredibly low. And so I think it's critical for people to realize that, people have asked me, well, do you keep your day job when you do a startup? Well, first of all, we'll talk about the reasons why you do a startup. But, if you love what you do, I would suggest that you continue to do it, because the probability of succeeding in a startup is actually pretty low. So let's investigate this a little further and talk about, how and why. So that first curve, where you go through what's called the valley of death, is where you start. And essentially, what happens is many of you guys have research labs, and in your research labs, you're developing things. And you're doing research and you're figuring out what works. And as you get further and further, you realize that, your ideas may potentially be beneficial to other people. And that's where you are in terms of, research and development. And you want to stretch out this phase, in my opinion, as long as possible before actually starting the company, because as soon as you start the company, you have a conflict of interest. And then it becomes extremely difficult to work on the things that you want to work on. You have to outsource them. You have to give your ideas to your friends and ask them if they will help you. Because once you have a conflict of interest, it becomes extremely difficult to publish papers that use your own technology. You have to get other people to work on it and publish those. Then you get to the middle, and we're gonna go through each of these phases in detail. So what's the first step, really? How does one contemplate a startup? I think there are two ways that people get here. The first way is people who say, well, I want to do a startup and I don't really care what it is. And then the second way is people who come up with an idea and then they realize that the only way to get it to work is by doing a startup. What both of these people have in common is that they have to have a lot of energy and optimism, and you have to sort of have this personality that is very, very resilient. And I think that most neurosurgeons will fall into this category. So the reality is that because of the nature of our work, we're sort of a specialty that's well suited to doing a startup. So what's the first, how did I get started, and what is the first essential component? So when I finished my residency, as Dr. Quinones said, I did a fellowship in Germany. So I arrived in Germany on June 24th, 2006. And at that time, I didn't even have sort of my credentials or my ID, and I didn't really have any permissions to do anything. And I had this book chapter that I needed to finish that was left over from residency. It was on vagus nerve stimulation. So I would say the first component to being able to do a startup is having time. And what I did was I spent most of July and August writing not just this chapter, but a couple of grants about vagus nerve stimulation to improve outcomes after brain injury. And I think the first key component in having a startup is having a job where you do not have huge demands on your time. So if you're, for example, going into private practice straight out of residency, or joining a group practice where they expect you to do 350 or 400 cases a year, you're actually suboptimally positioned to do a startup. I took a fellowship. I had a little bit of breathing time over the summer of 2006. It gave me time to write grants. It gave me time to think. And that really was where this all started. So I wrote this chapter on vagus nerve stimulation, and then I started designing a clinical trial. And the idea was that because vagus nerve stimulation has so many benefits for people who've had epilepsy and depression, that it may potentially have those same benefits in people who've had brain injury. So I designed a pilot randomized crossover blinded trial to ask, does vagus nerve stimulation augment recovery from persistently vegetative or minimally conscious states? And I had my outcome measures. And so my outcome measures were clinical, and I needed to have an objective outcome measure. So I thought, okay, I'll use fMRI, right? And so I designed this trial, and then the trial was designed so that we had assessments at particular time points, and then we had fMRI at particular time points. And this was based on work performed by other people that showed that fMRI may potentially be something that is indicative of recovery of function in people with severe traumatic brain injury and persistent vegetative state. So after about 4 years and multiple attempts, so my first attempt at writing the grant did not get funded. It actually, I resubmitted it to the DoD, and I finally got it scored so that it scored in about the 5th percentile. And then they funded 8 out of 204 grants. So I didn't make the cut. And I never got the DoD grant the first time, but I resubmitted the grant to the VA, and then I resubmitted it again, and I finally got it funded May 24th, 2010. So I would say the second thing that you need in order to do a startup is you need to have money. And that's really key component number 2. So you've got to have someone who believes in your ideas. At the same time as we submitted the grant, we submitted the IDE to the FDA. And this is where we met our first obstacle. The FDA did not want us to put minimally conscious or persistently vegetative patients into an MRI scanner. They said that if you implant a vagus nerve stimulator, they'll have metal in their body and they won't be able to tell you if they're distressed. So all of a sudden we had this obstacle. We needed to come up with a new outcome measure, right? Because the FDA wasn't allowing us to use the outcome measure that we proposed in the grant, which was fMRI. So you need to have an obstacle or problem. And I think this is one of the things about doing a startup that some people don't realize is, you may come up with a phenomenal idea, but if it doesn't serve an unmet need or get around an obstacle or problem, then it may not necessarily be marketable. And that's definitely something that one has to consider. So the obstacle that we had, the solution that we had to our obstacle was to develop a technology that we could use as an outcome measure after brain injury. And so the idea that we had was to see how well people could watch television. And the question we asked was, can we quantitatively assess how well brain injured people will watch television compared to normal people and use it as an outcome measure? Because we had this idea that people who were very brain injured would just stare into space, whereas people who were less brain injured would actually watch action on the screen. So we designed an algorithm where an aperture plays on a video, plays a video on a screen and it moves around. Now, what made our work different from all the prior work on eye tracking? So at that time, this is now 2011, there were about 2,289 papers on eye tracking. And in all of them, the patients were conscious. So what they did was they spatially calibrated the eye tracker. So they have the person look at a viewing monitor and then look at particular places on the monitor, and they spatially calibrate their eye movements so that they can tell where someone's looking in future testing. We, however, couldn't do that because we were planning on having minimally conscious and persistently vegetative patients. So instead of spatially calibrating, we used time. So we measured the Cartesian coordinates X, Y of the pupils over time, right? And that was our get around that we used. And the interesting thing about this is that was sort of the breakthrough that enabled our technology to do things that prior eye tracking technologies could not do. Because when you spatially calibrate, the patient has to be able to follow instructions. You tell them, look up, they look up, you measure the amount of light that reflects off their cornea, and that position is calibrated as up. Now imagine that you have a patient who, when you tell them to look up, one eye goes up and the other eye only goes 90% of the way up. If you spatially calibrate, you're canceling out that deficit. Whereas if you do not calibrate, you're not assuming anything. So this allows you to assess the function of not just the cranial nerves that move the eye, but also because you do pupillometry, you get cranial nerve 2, so you get 2 and 3, and because you do blinks, you get 5 and 7. So essentially what we've developed is a neural monitoring system that assesses cranial nerves 2 through 7. And that was sort of what we did, back in 2010, although it took us a little while to realize what exactly we'd done. So I would say the next thing that you need in order to have a startup is friends. So this work was done by computational neuroscientists at NYU, my colleagues, Marissa Carrasco, David Heger, and Shani Offen. And, in my opinion, in order to be successful in research at this point in time, you sort of have to have collaborators with competencies that you don't have. So I'm not a computer programmer. And David Heger was really the one who he had a huge experience with eye tracking. He's a neuroscientist. So, this is where this came from. And I don't think, it would have been impossible for me to start this company without that initial input from my computational neuroscience colleagues. So this was the original device. That's Talha Mahmoud. He was a research volunteer in the lab. And he's pretending to be a patient in the ICU. He's just sitting in a chair, actually. And we're having him watch Puss in Boots, which is a Disney video, and it's playing inside an aperture, and the aperture moves around a screen. And the aperture moves around the perimeter of the screen at a rate of 10 seconds per perimeter side. So it takes 40 seconds for it to do a full cycle. And it does 5 cycles. So we get 200 seconds of data. And then we tacked on 10 additional seconds at the beginning and the end so that we could capture the pupil. And so that's what the original device looked like. And this is what we saw. So we made what's called a box plot. So each time the video cycled around the monitor, we would record the XY Cartesian coordinates of the pupil over time. So as the left eye and the right eye traveled around, the first cycle would show up in red, then green, cyan, magenta, blue. So the video would start up here, and it would go 10 seconds, 10 seconds, 10 seconds, 10 seconds. So even though the viewing screen is a rectangle, the output is a square because it's over time, if that makes sense. And there's 3 ways to look at the data. This is what we call the box plot. This is what we call the time course, where the x-axis is time and the y-axis is the Cartesian coordinate. So when the video starts, x increases, so x increases and y stays the same. And then it gets to the upper right corner and y decreases and x stays the same, and so on and so forth as it goes around in a rectangle. And then finally, the third way of looking at the data is by comparing the positions of the pupils from the left and the right eye. And you can compare them in the horizontal plane, which is x, and you can compare them in the vertical plane, which is y. So delta x plotted over time is the top plot right here, and then delta y plotted over time is the bottom plot right here. And so now all of you, can imagine how powerful this can be in figuring out if the eyes are moving together or where potential deficits may be. So let's go to the next slide. So the simplest case is obviously a third nerve palsy, right? So you have a patient, they have a tiny little chronic subdural. You can barely see mass effect on the third nerve, but 2 out of 5 boxes are flat. Then the subdural gets bigger. There's clearly mass effect on the third nerve, and 5 out of 5 cycles are flat. Why is that? It's because the third nerve innervates the superior and inferior rectus. And if you cannot move if your third nerve has a palsy, your pupil doesn't go up and down as much. And so this is something that you're not picking up on physical exam, but the eye tracker is picking up because it's much more sensitive. It's a higher spatial resolution and frequency. Then finally, you treat the subdural. The mass effect does not look fully resolved on CT, but the eye tracking shows that the nerve is physiologically functioning better. So what you have essentially is a monitoring system that tells you about cranial nerve 3 function. Here's a patient with an acute epidural hematoma. So there's a guy who fell, he has a skull fracture, he has a tiny little epidural hematoma, and you can see his eye tracking, both of his boxes are flat. And he also has developed hypermetric saccades in the second half of his cycle. And so you see this sort of pattern of what looks like crazy eye movements. So he ends up going to the operating room. He actually became symptomatic from this. He developed a pronator drift. We took him to the operating room, and 7 days post-op, you can see that his third nerve is functioning normally because the height of the box is okay, but the hypermetric saccades are still recovering. So basically, the eye tracking is a physiologic monitor that tells you how well or how quickly the brain is recovering from an injury. So if the third nerve informs regarding supratentorial mass effect, the sixth nerve is going to inform regarding infratentorial mass effect. So here's a patient with a tumor on the back of his head. You can see that there's pressure on the sixth nerve. And so the box goes narrow. And this is independent, obviously, of hydrocephalus because this patient doesn't have hydrocephalus. And this is post-op day 1. So you take the tumor out and the box goes back to normal. Here's another patient. Here, the pressure is on the opposite sixth nerve. So the opposite box goes narrow because the sixth nerve moves the pupil out to the side. It innervates the lateral rectus. So the opposite box goes narrow. You take the tumor out and the box goes back to normal. So here you have a monitor that not only detects third nerve palsy, but it also detects sixth nerve palsy. Then you get a patient with neurosarcoidosis, presents with dizziness and headache. She's got hydrocephalus. Here's her pre-op eye tracking. You can see one box is narrow. Actually, this box is also flat. So she's got abnormal tracking. You put in the shunt, and post-op day 2, she's doing better. How old is this idea? It's funny, when I first started doing eye tracking, I looked back at the literature and I'm like, well, someone's probably done this before. And the reality is that the further back you go in the literature, as soon as you get to pre-radiology era, there's more and more literature on eye movements and brain injury. And actually the oldest writing ever in the history of medicine, based on texts written around 3000 BC, case number 8, is eyes that are askew are indicative of brain injury. So the idea is old. What's new is the idea of using eye tracking to quantitate it in a very rapid, non-invasive way. So the nice thing about eye tracking is that you choose where you look, but you don't choose the fact that your pupil movements are coordinated, and separate mechanisms control, for example, horizontal gaze and vertical gaze, and different mechanisms coordinate up versus down. So you've got separate pathways for each. And what we did when we developed this was we sort of made cases of each one of these. Like we could find a patient with medial longitudinal fasciculus injury. This particular case was from multiple sclerosis. And then we could document, we had a neuro-ophthalmologist, Floyd Warren, who collaborated with us, who documented that the patient had an INO. And then we showed that, with the eye tracking, you could detect this. And then the imaging, the MRI showed it was right there. So we actually patented each separate pathway. And we showed that eye tracking could pick up a deficit in each separate pathway. And so it's sort of a beautiful thing because you can localize an injury. Is it affecting just a cranial nerve? Is it affecting the nucleus that controls that cranial nerve? Or is it affecting the pathways that feed into the nuclei that control that cranial nerve? And so really that's what we came up with. And this is unpublished data. This is from our FDA submission. And it's patients with concussion. There are 135 patients with concussion, 665 controls. And what you can see is that the metrics these are the 12 most disrupted metrics in concussion. And what you can see is that different metrics inform regarding different types of injury. So these are metrics that inform regarding sixth nerve palsy. We've got some that inform regarding third nerve palsy. Blink length is abnormal in patients with concussion, and that suggests that it's pathways feeding into the seventh nerve. Pupil size is abnormal in some patients with concussion, suggesting that it feeds into the third nerve. So basically you have a monitoring system that not only picks up, frank nerve palsies or gross nerve palsies, but also disruption of the nuclei that control those nerves and the pathways that feed into those nuclei. And that's about 40% of the brain. Things like blink orphan ratio, fifth and seventh nerve palsies, opposite eyes. So this is a monitoring system, control that assesses cranial nerves 2 through 7. I won't need to go through this because we've got, a bunch of neurosurgeons on the call. So ultimately what you have is, you've got a new mechanism for assessing the central nervous system. And when you think about historically the way the central nervous system has been assessed, The oldest way is with physical examination, and that tells you about the physiology of the central nervous system. Psychiatric or psychological examination also teases that out. The problem with just using physical examination to assess nervous system function is huge functional heterogeneity among normal people, right? So suppose you came up with a test that determined whether or not someone has an intact cortex. And you could include in that test, math skills, reading skills, maybe piano playing skills, surgical skills. And the problem is that so much of that is learned and so much of that is affected by general heterogeneity that it's impossible to come up with a test that assesses cortical function without biasing it in some way to people who are predisposed to have learned something, to have learned language skills, to have learned reading skills, to have learned writing skills. So it's only by looking at primitive functions like eye movements that you can really, sort of assess, base physiology. Many of the means that we have of assessing central nervous system, focus on what the brain looks like. You've got X-ray, angiography, CT scan, MRI scan, which does give you some information about functionality. You've got EEG, electrical activity, you've got things that assess integrity. And this is probably the closest to eye tracking is assessment of pathways. You've got things that assess blood flow, that assess intracranial pressure or brain tissue oxygenation. But, none of these other methods assesses physiology the way eye tracking does. So what eye tracking is it's not a proxy for radiographic exams. It's a proxy for physical examination. It's a proxy for the follow my finger part of doing a physical examination. So let's go back to how to do a startup, right? So the first step is once you realize you've got something interesting, you have to submit a patent. So a provisional application is the easiest. For those of you who are affiliated with an academic medical center like Mayo, the way this works is, you basically call up your tech transfer office and it's relatively inexpensive for them to submit a provisional application. It's around somewhere between $600 and $1,000. Most academic medical centers, if you have a good conversation with them and they understand what you're doing, you'll be able to convince them to submit a provisional, regardless of whether or not you want to start a company, just because this is not a huge investment on their part. But, so I would say that the next thing that you need is you need to have lawyers. And, the funny thing is I was thinking, I was actually having a walk with a friend the other day and I'm talking about it. And I was saying that, med students tend to study in the med student libraries and they meet other med students, and really where they should study is in the law school library and meet lawyers, because I've never been sued and I've never sued anybody in my entire career. But I tell you, I spend more time on the phone with lawyers at this point than I do with any other segment of society. So having a good patent attorney on speed dial is your best bet if you want to start a company. So what comes after you file your IP? So we filed a bunch of IP in 2012 and 2013. What comes after that is you publish your papers. So detection of third and sixth cranial nerve palsies, we published in JNS. Eye tracking detects disconjugate eye movements associated with structural traumatic brain injury and concussion. We published in Neurotrauma, and then we had some other papers. So now I've got IP and I've got publications, and I've sort of established that, hey, I've got this new neuromonitoring system. What is my goal here? And my original goal was, and it still is my goal, is to change the way brain injury is diagnosed and defined. And I wanted to do that sort of completely independent of any other wishes. This is how I wanted to have an impact on the world, right? My options at that point were to give the tech away for free as open source. And that was actually my original plan. I thought that would be the easiest way to propagate this technology, was to put it on the internet, and anyone who had a research lab or, a clinician or a hospital could download the software, put it on their computer, hook it up to a camera and run it, right? And that was my plan. And then what disabused me of that notion was a conversation with people at the NYU Tech Transfer Office, who explained to me that if you try to give this away for free, it will never be a widely used technology. And why is that? It's because the way healthcare works, the only way to propagate a technology is to have a healthcare system profit from using it. So if they can't bill for your technology, they are not going to download it for free, and they are not going to use it on their patients. And that to me was that was a serious disappointment, because I thought that the best way to move very quickly was to make it free. And it turns out that what that does when you try and give something away for free is it creates a barrier to widespread incorporation in the healthcare system. My second option was to license the technology. So I actually tried that. So as soon as we started securing our intellectual property, I talked to a couple of different companies, and I said to them, hey, I have this thing. It's basically a monitoring system. Are you interested? And the first company I went to was Integra, because I used a lot of Integra products in the operating room. And the problem with them is that this is not in their wheelhouse. They don't market in this way, and they don't do this type of thing. So they weren't interested. The second company I went to was NuVasive. So NuVasive basically has a neuromonitoring system, right? I mean, many of us use NuVasive monitoring with spine instrumentation in the operating room. So I use it when I do, for example, my X lifts. And they were actually helpful, and they'll come into the story in a little bit. But they weren't interested in licensing the technology. And so then my third option was starting a company. And so the NuVasive, I actually met with the CEO of NuVasive, and he introduced me to one of his VPs for development who'd actually gone to NYU and was an alum from Stern, named Steve Ogilvie. And so Steve Ogilvie, who's pictured here, Rob Britlop, who was an MBA student at NYU, and I got together, and these guys wrote a business plan. And we submitted it to our Venture Tech Challenge at NYU, and we won $50,000. And that's how we started the company, because in the fine print of the award letter, it basically said, in order to cash this check, you have to have a legit company. And so that's what we did. So Steve Ogilvie from NuVasive was the first person to help me, and an MBA student, and that's really where this came from. So I would say the next thing you need is more friends. It's a lot easier to start a company within neurosurgery, because everybody will talk to you because you're already their client, right? Like if you ask Medtronic, Stryker, anybody that you use, if you use their stuff in the operating room, they're going to talk to you. They're going to be helpful to you. And the reason for that is that you're their client, and they don't want to upset you. I give literally millions of dollars worth of business to these companies. So that's how we ended up starting the company. So now that you've started the company, you've basically entered the valley of death, right? You've committed to diving off the cliff. And this is where you are. So my advice is, get as far as you can before you start the company, because the minute you start the company, you have that conflict of interest, and then it becomes a lot harder to go forward. So get as much IP as you can, secure your IP, write your provisional applications before you start the company. So now to explain about IP. So you guys, I know many of you guys have already gotten IP, and you know how to write a patent. But the way this works, for those of you who don't know, is you start with a provisional, and you create patent families. So these are 3 provisional applications that are in orange, and then you turn those, you bundle them together, you turn them into a utility application, which is filed a year after the first provisional in that series. And then you go through what's called the national phase, where you submit it in different countries. And then, so this particular application, it was 3 provisionals, it became 1 utility, and then it got issued years later in several different countries. The yellows are the issued IP. And then in the United States, it also got issued. So you can see that one application turns into multiple patent families. And so, for example, in our first applications, we applied for each of the cranial nerves, right? 2, 3, 4, 6, 5, 7. And all of the different pathways that feed into those nerves, and that's how you build your family. So that's the other thing you need. This part starts to get expensive. It's cheap to file a provisional. It gets very expensive when you do utilities and when you go into the national phase. And this is where you're going to need to start raising money. And this is, at this point, you may need to start the company in order to raise the money. What about ownership of IP? This is something that's really confusing. So inventorship is whose idea were the claims, right? Whoever comes up with the idea. Is it my idea? Is it my computational neuroscience colleague's idea? That's who is the inventor on the patent. Assignment or ownership is generally an employee obligation. So I work for the federal government, right? I'm a VA employee. I'm obligated to disclose to the VA and any academic affiliate with whom I'm working any IP that I have. And the VA has claimed my IP, right? So I assign to the VA. If you're at Mayo Clinic, you would probably end up assigning to Mayo Clinic. Now, the way that works is if I want to start a company, the VA can then license the technology back to me, or they can license it to somebody else with a right to commercialize. And then under most models in academia, the way they work this is it's 1/3, 1/3, 1/3. So if there's like a 3% or a 7% royalty on that license, then 1/3 of that 3% goes back to the inventor, 1/3 goes back to the department, and 1/3 goes back to the university. And I don't know how Mayo does it, but that's how NYU did it. So there's definitely, I would say it's good and it's bad. You know, if you have to assign to an academic center, they will help you. They are the lion, right? They will work with you while you're trying to develop your IP. They will assist you. And then when they own your IP, they'll help defend you. So if Google, for example, were to decide to go into the eye tracking for neurologic assessment business, they wouldn't be suing me, right? They wouldn't be suing Oculogica. They'd be suing the VA. The VA has buildings full of lawyers. They'd be suing the federal government because the federal government technically owns the IP. So, you know, Oculogica we basically did a license agreement with NYU and the VA back in 2000. It was December of 2013. And in the end, they started with almost 10% of the company, but now it's down to about, I think it's about 3.5%. So that's how that works. You know, and, you know, so the rest of the company is owned by the investors and other shareholders. Why do universities want to own your IP? Let's look at a case study here. So this is Caitlin Carrico. She was at Penn at the same time as I was, and in the neurosurgery department at the same time as I was. She started there before me in 1990. She submitted a grant application looking at RNA as a therapeutic, right? So she was going to modify the nucleosides and make it possible so that you could inject RNA into a human and it wouldn't be detected by the immune system and destroyed, right? And unfortunately, she wasn't particularly successful in her early years. So she at some point was on the tenure track and then was demoted from it. She actually joined the neurosurgery department in 1997. She became a scientist in Drew Weissman's lab. And Dave Langer, who some of you guys know from the popular Netflix TV series, actually worked with her in Drew Weissman's lab on this exact topic. So they submitted patents for modification of nucleosides to evade the immune response in 2005. And she started a company. She and Drew Weissman started a company called RNARX, and they had this goal of using RNA therapeutics to treat a wide variety of diseases, right? And they received SBIR grants, 900,000 in grants, right? Penn, so the company then failed. She was unable to get sufficient funding to continue the work. And so Penn then took the IP that they had apparently licensed to RNARX and licensed it to CellScript, right? And CellScript is a company that still exists. It's based out of Madison, Wisconsin, and its goal is to make RNA therapeutics. At the same time as she was having trouble getting her company off the ground, another group at MIT, basically led by Bob Langer, launched Moderna. And I mean, if you look back at the literature on this, it's actually kind of fascinating. It appears that they either tried to work around her IP or they may have done something else. But in any event, they launched their own company. Caitlin, in the meantime, continued to be frustrated with her efforts to work on this. And she left Penn in 2014 to join BioNTech, which is a German company that was also working on mRNA therapeutics and including on vaccines. And then the rest is history. In 2020, Moderna and BioNTech Pfizer both developed mRNA vaccines for COVID-19. So I've heard from the people at Penn that they've already started to receive royalty checks. So the reason that universities want to own your IP is that if your company fails, they want to be able to license the technology to somebody else so that the IP remains saleable. And so this is something that you should consider if you're going to start a company. Do you want to establish the IP outside of a university, or do you want to own it yourself? I mean, the advantage of having the university is that your IP will work at some point. If your idea is good enough, they will find someone who can commercialize it if you fail to do so. So that's something that you should consider. So in the meantime, we continued to publish papers. The next step, once you have a company, you can't work on things yourself. You have to have collaborators. So this was coming from Boston Children's Hospital. This is Children's Hospital of Philadelphia. This is Boston Children and Children's Hospital of Philadelphia collaboration. So those are our biggest collaborators. That's what you need, is you need to have other people who are willing to adapt your technology and publish papers on it. And then there were more papers that came out after that, some from our lab, mostly reviews from our lab, and then papers from other places. And we have a FDA breakthrough designation for elevated ICP with eye tracking. And we're running clinical trials at Penn, Johns Hopkins, and a couple of other places. So now what's the next step, right? So once you have IP, once you have your company started and you're paying for all your patent fees, what do you need to do next? Next is FDA. Then you've got to get, unless you already have a CPT code for what you're doing, you have to get CPT. And then finally, you have to get insurance companies and Medicare to agree to pay for it. And this is actually, in my opinion, the hard part. This is where you need someone who has experience doing that. You need what's, from a neurosurgery perspective, if you can do this, kudos to you. But I think you need a good CEO. And don't assume that, you as a neurosurgeon have the skill set or time to do this. So I would say a phenomenal CEO is what you need to navigate the next bit. We got through FDA on December 28th, 2018. We got CPT code on October 31st, 2019. And this is really interesting because the way you get a CPT code is you basically lobby organizations that may potentially benefit from the use of your technology. So we were delighted to get supported by like the emergency room physicians, by the athletic trainers, by both ophthalmology and optometry. And apparently they never agree on anything. So we were happy to be supported by them. And then the next step is fundraising, right? So when we started Oculogica, we started with a $50,000 university-based grant. We got additional funding from the New York City EDC, Economic Development Corporation. Then our first big grant was an NSBRI, which was $250,000. Then we got a SBIR in conjunction with Children's Hospital of Philadelphia. And that was a seven-figure grant. And then more recently, we got another seven-figure grant from DOD. And I think I found out about that when I was on the phone with Dr. Quinones. So I was super happy about that. So that's really, I know people who started companies and haven't raised any dilutive funding. They've done it all with SBIR grants. If you're good at writing grants, you can do this. I have about, our company and myself, I have about somewhere between a 15 and 20% success rate with grants. So it's low. Am I behind time? Okay. Okay, then I think there's some background noise. I'm not sure what it is.
I'm sorry. Yeah, some background noise. Maybe Gaetan, if you can mute.
Yes, sir. I muted them.
It's on the background. That'll be great.
Okay, great.
Okay,
And then,
thank you. Continue, Uzma. There you go.
Yeah, and then the next step is equity investments. So we were lucky. We're from Wisconsin. We had some friends in Wisconsin, and we were able to get the Green Bay Packers Titletown Tech to lead an $8 million round of funding for us. So I would, and here's where I would throw out a word of caution. When it comes to valuations, you don't want to raise so much money that when you go through the peaks and troughs, you crash. Here's a company, Vicus, they raised 28.5 million in a Series B after they raised a total of $84 million. And then they ended up not being able to raise a next round. And when that happened, they had to sell their assets, for 2.85 million. So their investors lost money. So like I said, a good technology will succeed, even if it has to succeed in someone else's hands. What you want is you want it to succeed in your own hands. So hopefully you can find a CEO who will help you with that. So what's the final, where does this end, right? Well, there's three possibilities. You can buy out your investors and have a private company, or you can do what's called a SPAC, which is a special purpose acquisition company. And what it is when you get a lot of people with money to get together, form a SPAC, and then they basically buy out a technology, and then they get it acquired or convert to an IPO. And then the third possibility is you get acquired. And then what happens next is you start another company. It seems like this is addictive. A lot of neurosurgeons who do this have started more than one company. I am by absolutely no means one of the more successful neurosurgeons at this. There are many neurosurgeons. I think there's a session at the CNS featuring entrepreneurs, and there's probably about 10 neurosurgeons who are speaking who've all started multiple companies and been massively successful. What is the end game? Really, it's, do you want to have a company that is small and just does what it does? You want something that's acquired, you want a SPAC, you want an IPO, you're going to make another startup. The reality is that most startups fail. The likelihood of it surviving is higher the more funding that you get, but still most startups fail. I think this is the cumulative likelihood of acquisition. So if you're pre-Series A, you have about a 30% chance. If you have to get to about a Series B in order to have a greater than 50% probability of getting acquired. So it's still a long shot. People have, so now in my career, I started at the VA, and the VA is kind of the perfect place to do a startup because it's a low pressure work environment and you get time to work on ideas and think about things. And then, for a while I was working a lot more. I was doing about 400 cases per year at a level 1 trauma center. And now I've cut back again. I'm now private practice, and I'm still at the VA. I've stayed at the VA the entire time. In my opinion, if you really want to do this, I think you should try and have a job where your main focus is not operating. You want to have a decent chunk of your time, a couple of days a week, to work on this. And so really that's it. I'll end there. And I hope I'm not too far over time and I can take questions. Thank you.
Beautiful, Dr. Samadani. I get so many compliments in the chat as we're going along. I think Dr. Rodman also, who was a postdoc in our lab, who now runs the Mayo Clinic Ventures Innovations. And that was part of the alligator tank, that we have. I see a question by Dr. Lee James, who's going to be, by the way, you saw he was the recipient of the Young Investigator from the American Epilepsy Society. So he's one of our GY2 residents. Go ahead, James.
Dr. Samadani, thank you so much for the great lecture. So when you're doing these very complex sort of startups, as a trainee, did you have like a business mentor or someone to take you through all of these complex laws and things that you have to go through in order to start something legal? I was wondering what your thoughts were on that.
Yeah, so I think yes. So there was a resident in our program at Penn named John Abrams who was super helpful to me. There were other people. I would say that your first resource is the tech transfer office at your academic center. So become good friends with the tech transfer personnel. And you like have them on speed dial, you know what I mean? And that way you can sort of get advice from them on a day-by-day basis. This, like I said, the second resource is neurosurgeons who've done it before. So in my case, it was John Abrams. John Adler at Stanford was also a huge help to me. He's fantastic. I would send him an email every now and then, and he would respond with "add a girl" or something like that. He gives a great talk on how to do a startup. I think with Cyberknife, which was his first startup, he basically almost went broke many times and still succeeded, obviously brilliantly. So he's a great resource. You definitely want to find a neurosurgeon who's been there, done that. I know you guys have Dr. Chin that is down there in Florida, so maybe you can ask him for advice. But certainly they will help. And then the third part is a lawyer. So we started out with the NYU's lawyers and the VA's lawyers. And, like I said, I feel like I spend a lot of time on the phone with lawyers to this day. Every time we're in the news, the VA lawyers call me and I talk to them. Every time, we still deal there. It turns out that there was a lot of, I guess the word is conflict between NYU and the VA regarding IP. But they spent a lot of time on the phone with each other, and now I think they've worked most of it out. So there is always that. When I left NYU, there were 7 lawyers involved in my transition. They were representing the VA, NYU, University of Minnesota, Hennepin County Medical Center, the company, and me. So it gets very complicated. That's just how it is. But lawyers, you definitely need, like I said, go study in the law school library, not the med school library. I think every neurosurgeon should be friends with lawyers. It really makes it a lot easier. I have a lot of friends who are lawyers now. It makes it a lot easier to just curbside and ask questions and not have to pay fees every single time. And that sounds like a terrible relationship, but they get stuff from us too, so there is that.
Mm-hmm.
Okay.
Gotcha. Thank you very much.
We do it all the time ourselves, it's great. So Uzma, when did you, what part of your training, because I think this is a relevant question from James, what part of your training did you start thinking about the company?
Well, I was already done with my training when I came up with this idea. I finished my training in 2006. I finished my fellowship in 2007, and I started we started working on eye tracking in 2011. It took us that long to get funded. Nowadays, I've talked to residents who are trying to do startups much younger, and I think it's great. I think, I'm of the school of thought that if we're going to push the field forward, it's people who are in the field and know the problems associated with what we're trying to solve, that are going to do it. So I actually encourage residents to do it, early. The key thing is don't think that you can be the person driving the company forward when you're a full-time clinician, especially when you're a resident. You need to have like a proper CEO and a proper, like even a CSO, because you may think that you're the CSO. You don't have time to be a CSO. You're not the CSO. You're scientific founder, but you don't have time. You think as a resident you do, but you don't. Because these are people who are doing nothing all day but working on your company. And so that's really what you need, in my opinion. I mean, maybe there's an exception that proves the rule. There's a resident who's done it without having a team, but I really think you need a team. Other questions?
I agree with that. I was just going to say, secure IP first. The idea is put the IP. This is what we're trying to do, with the alligator team, with ideas, prototypes, and things like that. And then once you finish your training, as Dr. Samadani did, you can begin to start thinking about putting a company together. That would be my advice. I think that I've seen a lot of residents trying to do this during residence, and then they fail to train as good clinicians. They fail to recognize their problems, and almost 100% of the time their companies also fail because they were just not ready, for that. So become a good clinician, put your IP, you know, and just as Dr. Samadani said, once you come out in the real world, you have your ability to take the boards. That's what she did. She took her oral board. She became board certified in neurological surgery. This is why we're both examining, you know, future trainees. And you can see when she began to put the company together. So wonderful, Uzma. So I'm sorry that we kept you over time. I know you're supposed to meet the residents. So if it's okay, Andres, we have an agenda for Dr. Samadani. Can you just tell her where she's going to go next? It's like, I think it'll be great for her to meet some of the residents for a few minutes, and then she's got some faculty to meet.
Yeah, so we have about 10
yeah.
minutes with the residents. So there's another link that we sent. So we're going to use that same link for all meetings. So we have a couple minutes with residents and us, and then the faculty, and then with Dr. Quiñones.
Okay, perfect. I'll go to the other link then. Thank you.
Awesome.
Yep. Thanks, everybody.
Great. Thanks, everybody. Have a great week. Beautiful talk, Uzma. Thank you.
Thank you.